My name is Milton Awiti, and I'll be presenting alongside Valeria on our project, which is aimed at developing a heart rate monitoring app. So the goal of the project is to provide users with easy app that tracks their heart rate over time. The app will fetch heart rate data from the Fitbit, store it securely, and provide insight to the user. Then the role on creating a smooth interactive front end and back end allows users to log in securely, view heart rate data, input daily stress levels, and fetch and save heart rate data from the Fitbit. So I'll be handling the front end part, while Valeria will be handling the back end part of the project. So starting on the front end part, so the project integrates IOMT to fetch, display, and save heart rate data. So I worked with Figma, Flutter, and integrated the front end with the back end to heart rate data. And then on Figma, as you can see here, I designed various pages that I will later use in Flutter. So I have a home screen page, I have a login page, I have patient filling, patient connection, and data view page. This will help me in at least building my Flutter so that I can know what's needed for my health monitoring app. So some of these pages, for example, the home screen page and the logins page. So home screen page for this case allows the user to at least see what is expected of the other pages, and then the login page allows the user to enter their credentials securely. And then so like the home screen page is like the main dashboard, and then from here we'll be having like the patient filling, the heart rate fetching, and the data view. So we also have the buttons, and these buttons will be helping us with the navigating through the pages. So I'll go ahead and show my Flutter app. So here we have the main data, which is this is the main entry point, and then we have the query data codes and the save data codes that will be used in displaying the collected data from the patient. So I'll go ahead and display how this data is fetched from the front end part of it, and then we'll again see how this process goes step by step on the back end part of it. So I will display it on Android emulator. Which will go ahead and take us to the pages that I've mentioned before. Yeah, so the emulator is currently launching, and it will take us to the pages so that we can fetch the patient data or the user's data. So here we can log in and go to the data search, and from there I had my dates from 23rd February to 25th February. So this one, when I click the fetch heart rate button, it will display the information there. But remember, I have done the security checks, as you can see here, for the Fitbit Auth. And let me see here. sorry. Yeah. So yeah, it's here. So I've done the security checkings where it successfully got the access with the user's ID, and the status code is 200, which shows a successful test. And from there, I'll now go to saving the data that has been displayed, and I'll be using just 1 day to collect the data to the DynamoDB table. So next I will demonstrate on how to save 1 day heart rate data by using Postman. So first I will come to the save heart rate function and test it here. Yes, it has successfully collected the heart rate data, and I've done that before. So let me just change to a different date. So I have 4, 5. Let me change to 7. Okay. Then let me check if it's updated. So when I run it, here, it's already updated. Next, I will go to Postman to check. So here, because I have 4, 5, 6, 7, so I will do 8 to see if there's any change on the tables. Yes, so it's collected it successfully. When I update it there, it can show that 8 is existing on our table. Thank you. Yeah, so on this part, I'm going to record a video to demonstrate how you can use CloudWatch metrics to monitor schedule invocation of auto refresh token Lambda function. So first, I'll go to EventBridge, and already I created here. I went to rule, and I created a rule here. So that one is already created, and I can find it here on the schedules. Yes, so it's here with the target as our auto token refresh function, which we'd created sometimes back. Yeah, so here we have the scheduled, that is, it triggers event after 1 hour with our target being auto token refresh. So we can go to our function, Lambda function, which is top the auto token refreshed, in order to monitor schedule invocation of auto refresh token Lambda function. So here we'll go to monitor, and then set it at 1 day. Yeah, yeah, is it? Let me see. Yeah, 1 day. It's here. Yeah. So from here, it will trigger after every 1 hour. Yes. Thank you.
Hello, my name is Valeria, and I'm going to take you through the backend demonstration of the IoT-based stress monitoring system project. So the goal of this backend is to securely collect and manage stress-related data, including Fitbit heart rate data, using the AWS cloud services and the RESTful APIs. So this project will cover how we used the API gateway, Lambda functions, and DynamoDB, as well as EventBridge to support data collection, data processing, and data storage. So I will walk you through how Fitbit's authorization process is used to gain access to wearable data from a user's Fitbit device. So first of all, I would like to briefly explain the key backend components, starting with API gateway. So it acts as the entry point for requests coming from the mobile app. It exposes secure endpoints that trigger backend processes. And then the Lambda functions are where all the logic happens. They handle tasks like authenticating Fitbit users, retrieving heart rate data, and storing it into a database. So DynamoDB is a serverless, no SQL database service that stores user Fitbit tokens and heart rate data securely. And then lastly, EventBridge can be used to schedule regular events, such as refreshing Fitbit tokens automatically or triggering daily data sync. So going to the Fitbit authentication process. I will start my project by walking through the Fitbit website, which is used to generate an authorization code. Right, so that's our Fitbit developer portal. So we have to register our app, and then we'll get to this URL, which we have to copy this code up here. And then we'll come and paste it here. And then we've generated our authorization code right there. So this code is necessary to obtain access and also refresh tokens that allow our backend to retrieve patient heart rate data from Fitbit. So after receiving the authorization code, we'll use the Fitbit auth Lambda function to exchange that code for an access token. So this is our Fitbit auth. And then I would like to show the code right here. Copy it. And then we'll replace it there. And then we'll test it. We'll test it. If this shows that it has been successful, right? So as you can see, the function successfully returns both an access token there and the refresh token, and this information will be stored in our DynamoDB. So here's the same request tested in Postman. So I sent the authorization code in a post request to my API gateway endpoint that is connected to the Fitbit auth Lambda function, right? And okay, so we'll test it again. We'll get the code again so that you can refresh. The code, and then take it to a Postman. Okay, we've generated our code. It should take to a Postman. Okay, great. So this now confirms that both the AWS Lambda and API Gateway are properly integrated to handle the Fitbit auth process. So now that we have obtained a valid token, we can use it to retrieve the user's Fitbit heart rate data using the get heart rate Lambda function. So just go to the get heart rate Lambda function. And then we have our test event here that we already tested. Yeah, and it's showing that there's a sample response. So this function pulls heart rate data for specific state and Fitbit and prepares it for visualization or analysis. So here's the same process being tested in Postman using the API Gateway endpoint. So the API returns heart rate data for the requested date, confirming that Fitbit data is being securely and successfully accessed via our backend. Let's run that again. Okay, it's successful. So now let's look at the Fitbit token from our DynamoDB table, where the token and possibly heart rate records are now stored. So open our table, and each record here in the table includes the user's token and associated data like timestamp or token type. And this will allow us to store and retrieve data reliably for each individual. So to close this up, this backend system integrates Fitbit and AWS Lambda API Gateway in DynamoDB to provide a secure, scalable solution for managing wearable health data. And the Fitbit auth process is handled through a dedicated function, and patient heart rate data can be accessed and stored for stress monitoring analysis. And this architecture ensures that sensitive health data is collected securely and enables daily monitoring for wellness support.
Yeah, so on this part, I'm going to record a video to demonstrate how you can use CloudWatch metrics to monitor schedule invocation of auto refresh token Lambda function. So first, I'll go to EventBridge, and already I created here. I will went to rule, and I created a rule here. So that one is already created, and I can find it here on the schedules. Yes, so it's here with the target as our auto token refresh function, which we'd created sometimes back. Yeah, so here we have the scheduled, that is, it triggers event after 1 hour with our target being auto token refresh. So we can go to our function, Lambda function, which is top the auto token refreshed in order to monitor schedule invocation of auto refresh token Lambda function. So here we'll go to monitor, and then set it at 1 day. Yeah, yeah, is it? Let me see. Yeah, 1 day. It's here. Yeah. So from here, it will trigger after every 1 hour. Yes. Thank you.